Hello everyone, I welcome you all to this video lecture. So far we have discussed the uniform and varying acceleration. In both uniform and varying acceleration, the particle move in the horizontal direction. Suppose if the particle moves in the vertical direction, then it is considered as the motion of a particle under gravitational force because the particle is moving with the acceleration due to gravity. That is why you can see that the acceleration is replaced by g. And the important point about the motion under gravity is when the particle is moving in the vertical direction, the gravitational force, that is the acceleration due to gravity, is constant throughout the travel. So that is why it comes under uniform acceleration. There are two possibilities of motion of a particle under gravity. The first one is downward motion. So here the particle moves in the downward direction. Then the second possibility is upward motion. Here the particle is moving in the upward direction. So if the particle moves in the downward direction, then the acceleration due to gravity is acting in the positive direction. We know that the acceleration due to gravity acts in the downward direction. That is why here the v is equal to u plus gt. The s distance is replaced by h since the particle is moving in the vertical direction. So here the h is the height. H is equal to ut plus of gt square. Then v square is equal to u square plus 2gh. Suppose if the particle moves in the upward direction, then the particle is moving in the opposite direction of the acceleration due to gravity. That is why here the direction of the acceleration due to gravity is considered as negative. B is equal to u minus gt, h is equal to ut minus half gt square, and v square is equal to u square minus 2gh. So here h is the height in meter and g is the acceleration due to gravity. We know that the g is equal to 9.81 meter per second square. So the first problem is a stone is dropped from the top of the tower. So here the stone is dropped from the top of the tower. The stone is moving in the vertical direction. So this problem comes under motion under gravity. And the stone is dropped from the tower. So the stone is moving in the downward direction. So it is case 1. Find the height of the tower and the velocity of the stone when it reaches the ground surface. The stone is dropped, which means the initial velocity u is equal to 0. So that is very important. If the stone or if the particle is dropped, then the initial velocity is equal to 0. Then it reaches the ground in 8 seconds. So t is equal to 8 seconds. Okay, so now we have u and t values. We have to find out the value of, to find the height of the tower and the velocity of the stone when it reaches the ground surface. So height of the tower is h and the velocity of the stone when it reaches the ground surface is the final velocity v. So we have to find the h and v. So go to the equations. We have u, t, and we know that the gravitational force g is 9.81 meter per second square. Okay. So if you take the first equation, we have v, g and t. The only unknown value is u. So we can use the first equation, that is v is equal to u plus gt. Okay. And further, so v is equal to u is 0 plus 9.81 into 8. So if you solve this, you will get the velocity as 78.48 meter per second. Now we have calculated the value of the velocity, final velocity. Then we will calculate the h. If you consider the third equation, we have v, u and g. The only unknown value is h. So we can use the third equation. that is v square is equal to u square plus 2gh. So we can substitute the values. The v we have already calculated, 78.48 square, that is equal to, the u is 0 plus 2 into 9.81 into h. So if you solve this equation, you will get h is equal to 313.92 meter. Okay. Then the second problem. A stone is dropped from the top of the tower of 100-meter height. At the same time, another stone is thrown upwards from the ground. Both the stones meet at a height of 25 meter. Find the time when the stones meets each other. So let us try to construct a simple drawing. So this is the tower. The height of the tower is given, that is 100 meter. So the first stone is dropped from the top of the tower. Since it is dropped, the initial velocity is 0. The second stone is thrown upwards at the same time. So here the second stone is thrown upwards. So both the stones meets at a height of 25 meter. So this height is 25 meter. So the overall height is 100 meter. The stone 2 travels a height of 25 meter. So the remaining distance is travelled by the stone 1, that is 75 meter. Okay, now for the stone 1 we have u is equal to 0 and the height travelled by the stone 1 is 75 meter. So we have to find out the time when the stone meets each other. So we have to find the value of t. So in this problem we have u and h, and already we know that the g is 9.81 meter per second square. We have to calculate the value of t. So if you take the second equation, the h is equal to ut plus half gt square. Since the stone 1 is moving in the downward direction, here it is positive. So substitute the value of u, h and t. So u is 0, so plus half into 9.81 into t. The h is 75. It is t square. So if you solve this equation, you will get t is equal to 1.25 seconds. So in the problem, the total height is 100 meter. So among the 100 meter, stone 2 travels a height of 25 meter and stone 1 travels a height of 75 meter. So we are calculating the time taken by the stone 1 to meet the stone 2. So we have to consider the height of stone 1 alone. So that is very important. So if you consider the height as 75 meter, then we can calculate the time as 1.25 seconds. Then the third problem. A stone is thrown vertically upwards from the ground with a velocity of 49 meter per second. Determine the maximum height reached by the stone, time taken to reach the maximum height, total time of flight. So first we will calculate the 3. So the given is the stone is thrown upwards with an initial velocity of 49 meter per second. So here the initial velocity u is 49 meter per second. So since the stone is thrown upwards, it comes under case 2, that is upward motion. Okay, fine. So first the maximum height h. So the maximum height means the h at v is equal to 0, because at the maximum height the particle loses its velocity. So the final velocity will be equal to 0 at the maximum height. Then the second one is time taken to reach the maximum height, t at v is equal to 0. Then the third one is total time of flight, that is capital T. So the total time carried by the stone. So actually the stone is thrown upwards and it reaches the maximum height, then it comes back to its original position. So the traveling time by the stone to reach the maximum height is t, and from the maximum height the stone takes the same time to reach the ground. So the total time of flight capital T is equal to 2 times the small t. Okay, so first we will calculate the h. So in this problem we have the velocity value and u value. Also we know that the g is equal to 9.81 meter per second square. Okay, so if you use the third equation, that is v square is equal to u square minus 2gh, we have the value for v, u and g. The only unknown value is h. So we can substitute the values. So v is 0, u is 49 square minus 2 into 9.81 into h. So if you solve this equation, you will get h is equal to 122.37 meter. So we have calculated the value of h. The second one, the time at which v is equal to 0. So now we have the u, g, v and h. We have to find out the value of t. Okay, so here we can use the first equation, that is v is equal to u minus g t. In this equation we have v, u and g. The only unknown value is t. So we can substitute the values. The v is 0, the u is 49 minus 9.81 into t. So if you solve this, you will get t is equal to 5 seconds. And I have already told that the capital T is equal to 2 times the small t. So the total time of flight t is equal to 2t, that is equal to 10 seconds. So this is the first part of the problem. Then the second part is, after 2 seconds, another stone is thrown vertically upward from the same plane. If both the stones strike the ground at the same time, find the velocity with which the second stone was thrown. So here, another stone is thrown after 2 seconds and it reaches the ground at the same time. So the total time of flight by the second stone. So if both the stones reaches the ground at same time, the total time is 10 seconds for the stone 1 and the stone 2 is thrown 2 seconds after that. So we can subtract 2 seconds from that. So the time of flight for the second stone is 8 seconds. So that is very important because the stone 2 is thrown after 2 seconds. So it is 10 seconds for stone 1 minus 2 seconds is equal to 8 seconds. So if the capital T is 8 seconds, we know that the capital T is equal to 2 small t. So small t is equal to 4 seconds. Now we have to find out the value of velocity with which the second stone was thrown, that is the initial velocity. So u we have to find out. So in the second case we have the value of t, g and the final velocity, because the final velocity is 0. Once the stone reaches the maximum height, its final velocity is equal to 0. So by using the first equation, that is v is equal to u minus gt, we have the value of v, g and t. We can find out the value of u. We can substitute that. V is 0, u minus g is 9.81 into the t is 4 seconds. So if you solve this equation, you will get u is equal to 39.2 meter per seconds. So the important point about this problem is, at maximum height the final velocity will be equal to 0. Thank you.